So in number 2, we're also using the Pythagorean theorem here. We just have a slightly more complex numbers to deal with. So as I plug numbers in from the diagram into the Pythagorean theorem, I've got to recognize the longest side is 2 times the square root of 3 miles, so that's what I'm going to put over here. 2 times the square root of 3, and that's what we're going to square. The other ones, I'll call the leg here A, or if you want to change it to X, you can change it to X, that's fine. And then we're going to talk about the other leg being B, so 2 times the square root of 2 squared. Okay, so nothing changes in the way that you set it up. It's just a matter of squaring those terms that have the radicals in them, which can be a little tricky from time to time. So that I'm going to bring down as just x squared. Here, when I square this, I'm really taking 2 squared, which is 4, and I'm taking the square root of 2 squared, which is going to be 2, and so ultimately it's going to be 4 times 2, which is 8. Okay, so when I take all of this stuff, squaring it, I get 8. Okay, the same kind of thing happens here for the hypotenuse squared. 2 squared is 4. The square root of 3 squared is 3. So altogether that's really 4 times 3, which is 12. Okay, so once I get back past that squaring, now my values become a lot easier. I'm going to take away 8 from both sides, so that I'm left with just x squared, and that'll be 4 over here. And now when I take the square root of both of those, I get x equals, if you're thinking about this in terms of algebra, you would say plus or minus 2. Okay, a square root of 4 is technically plus or minus 2. The problem with saying that as an answer here is because we're talking about an actual specific distance that has to be positive, so x in this case has to be 2.